Hello class, welcome to chapter 9.4, solve polynomial equations in factored form. So let's get started. That's the best way to kind of see what we'll be learning. So the first thing is the zero product property. The zero product property is used to solve an equation when one side is 0. So this is very important. When one side is 0 and the other side is a product of polynomial factors. So this is the main thing right here. Okay, one side must be 0. Okay, and the other side is a product of polynomial factors, and you'll see different forms of that throughout this video. The solutions of such an equations are called roots. The roots balance out the equation. So let's take a look at this. So if I say solve parentheses x minus 4 and x plus 2 equals 0, what I'm going to do is this is in the product of a polynomial factors form. Okay, and you'll see one that's not in form yet. So this one's already simplified. So what that means is I'm going to take each one inside of the parentheses and set it equal to 0. Okay. So I have these two binomials. I'm going to set each of them equal to 0. And then I'm going to solve for x. So I'm just going to add 4 over. X equals 4, or subtract 2, x equals negative 2. Okay, so these are my roots. Okay, those are the solutions. Okay, roots. Now, remember what I said, the roots balance out the equation. So if I plugged in negative 2 for x, either x, I could plug it in for either x, but I know in this one, if I plug negative 2 in, I get 0. So 0 times whatever would happen in that equation, doesn't matter, it would be 0. So 0 does equal 0. If I plugged 4 in for both of my x's, I could plug 4 in here, 4 in here. I get 0 here, and I get 6 here, but 0 times 6 is 0, so it balances out. So the point of this section is to find out what x equals, or in the end what you're going to find out is what we don't want x to equal. So it could be all real numbers except for 4 and negative 2, but as of right now in this section we're just going to leave it as x equals 4 and x equals negative 2. So again, one quick thing, make sure it's set equal to 0. If it's not set equal to 0, you have to make sure you add or subtract whatever's on that side to get it to equal 0, and then you can start solving from there, and you'll see. So the first thing before we include that equals 0 again is we got to talk about find the GCMF, which means the greatest common monomial factor. So what we're going to do is look, and this is two problems here. So let's look at problem number 1. Now we're going back to when we learned about greatest common factor. We have 12x plus 42y. The first thing that I like to look at is the variables. So we have an x here and a y here. So they do not have any variables in common. Okay, but now we have 12 and 42. So when we looked at the factors of 12 and 42, we know 1 and 12, 2 and 6, 3 and 4. Okay, and when I look at the factors of 42, I know that 1 goes into it 42 times. Okay, I know that 2 goes into it 21 times. I know 3 goes into it 14 times. I know 6 goes into it and 7. So here are my factors of 12 and 42. Now I'm going to find the greatest factor that they have in common. And it looks like the greatest common factor that they have is 6. Okay? So we're going to pull a 6 out of that equation. So if I pull a 6 out, meaning really I'm dividing each of those by 6, I'm left with 2x plus 7y. Okay, and that would be my final solution. This is not set equal to 0 yet, so we're just leaving it in the greatest common factor form. So I take out the greatest common factor, and then I simplify it. Okay, so 6 parentheses 2x plus 7y. You can look here inside your parentheses and see, inside my parentheses, do they have anything else in common? Well, 2 can't go into 7. So the coefficients of the x and the y, they do not have anything in common, and x and y are different. So this would be my simplified answer here. So let's look over on this side. We have 4x to the fourth plus 24x to the third. So again, I like to look at our variables first. They are the same, x to the fourth and x to the third. Now I'm going to take out the greatest number that they have in common. So this is x to the fourth, and this one is x to the third. So the greatest number that they have in common are 3. So I'm going to take x to the third out. Now I'm going to look at the factors of 4 and 24. Well, we know that 4 goes into it. So here's my factors. Sorry. Got ahead of myself there. Come on. 3, 4, 6, 8, 12, 24. So we know that the greatest common factor here is 4. So I'm going to take a 4x cubed out. And when I take a 4x cubed out, okay, I'm dividing each of these by 4x cubed. Now this is kind of going into what we learned, last chapter. 4 divided by 4 is 1. And x to the fourth divided by x to the third is just x, plus 24x to the third divided by 4x to the third. 24 divided by 4 is 6. And x to the third over x to the third, they cancel each other out. So that is my simplified answer there. So this is the most important thing, is taking out the correct greatest common factor. And again, look inside of your parentheses after you have completed that. And if it still has something in common, then you did not take out the greatest common factor. Okay? So let's take a look here. Here's an example, 14m plus 35n. Again, what I like to do, look at the exponent first, or I'm sorry, the variable. We have an m and an n, two different ones, nothing in common then. Okay, so we can't take out a variable. So then we look at 14, we know it's 1, 2, 7, and 14. In 35, we know 1, 35, 5, and 7. So greatest common factor is a 7, so I can take a 7 out. So I have 2m left plus 5n. So again, remember that greatest common factor, we're multiplying each of the terms in our problem by. So you're left with 7 parentheses 2m plus 5n. Again, to make sure your answer is correct, look at what you have inside of your parentheses and make sure they do not have anything in common with your greatest common monomial factor. So let's take this one step further now. Solve an equation by factoring. So we have this equation that's set equal to 0, which we want. So now we have to look at the left side. Now if we go back to how we started this video, we had parentheses already and everything solved for us. This one is not. We're going to have to factor this. So look at 2x squared plus 8x and see what their greatest common factor is. So again, I look at their exponents. Do they have an exponent in common? Or a variable? I'm sorry, I keep on calling that exponent. A variable, and they do. They have an x in common. Well, this one has 2 x's and this one has 1x. So 1x is the greatest number that they have in common. Now we have 2 and 8 as our coefficients here. So we know that 2 is just 1 and 2. And we know 8 is 1, 2, 4, and 8. So the greatest common factor here is 2. So we take 2x out of this, meaning we're going to divide each of those by 2x. And that's what's going to be left over. So 2x squared divided by 2x is just x. These cancel out to be 1. And then x squared over x is x minus, or 2 minus 1, which is just x to the first power. And then these x cancel each other out. 8 divided by 2 is 4. Okay, now since it's set equal to 0, we have to solve it even further down. Because remember, when it's set equal to 0, we're trying to find out what will balance this equation. Okay, so what would balance that equation? So going back now, you have to set what's inside the parentheses equal to 0. Or if you take one of your greatest common factors is a variable, we have to set that equal to 0 as well. Okay, so if your greatest common factor is just a number, a whole number, we do not need to set that equal to 0. But if you take a variable out, we have to set that equal to 0. So here, divide by 2, x equals 0. Subtract 4 over, x equals -4. So here are my two solutions now. Now, if I rewrite this problem, I only get 15 minutes, so I'm going to move a little bit quicker. So, quickly. Plug in 0. Well, I know 0 squared is 0 times 2 is 0. 8 times 0 is 0, so this equals 0 equals 0. -4. -4 squared is 16. 16 times 2 is 32. 8 times -4 is -32, which equals 0. 0 equals 0. So both of these check out. So you can check your solution by doing that. Okay? So here, look at this problem right here. Now, it's not set equal to 0, but we can easily do that. So we're going to subtract the 15n. Now, these are not like terms because they have a different exponent. This has an exponent of 2 and this has an exponent of 1. Okay? Now we have to take out the greatest common factor. So we have an n squared and an n, so the greatest one that they have in common is 1n. Then we look at 6 and 15. We know 6 is 1, 2, 3, and 6, and 15 is 1, 3, 5, and 15. So 3 and 3, so take a 3n out. So divide each of these by 3n. And I'm left with 3n, I'm left with 2n minus 5 equals 0. Now I took out a variable here, so I have to set that equal to 0. So 2n minus 5 equals 0. Add 5. 2n equals 5. Divide by 2. N equals 5 over 2. So n could equal 0, or n could equal 5 over 2, or 5.5, however you'd like to label that. Okay? I only have 2 more minutes, so I'll solve what I can solve, and then the rest for homework. Here's some homework problems that you have to work on, so just in case I don't get to those here. So here we go. Here's some more examples. So it's set equal to 0. Good, check. We can take out the greatest common factor. Well, they have s squared and s. Well, the greatest number that they have in common is just 1s. Greatest common factors of 3 are 1 and 3. And 9 are 1, 3, and 9. So we know we can take out a 3. 3s. So we divide each of these by 3s. We're left with s minus 9 divided by 3 is 3 equals 0. Well, I took out a variable, so I have to set that equal to 0. Divide by 3, s equals 0, or s equals 3. So again, plug these solutions back in separately. Plug in 0, make sure that it balances it out. Plug in 3 to make sure that it balances each other out. So here, it's not set equal to 0, so let's bring that over. Subtract 2x. This will be my last problem. Okay, you can do this one on your own along with the homework. Okay. Make sure it's set equal to 0. First thing we did, take out the greatest common factor. Well, they have an x in common. That's the greatest number that they have in common. Factors, take a 2 out. So I'm left with 2x minus 1 equals 0. Set this equal to 0. Set this equal to 0. And solve. So x equals 0 or x equals 1/2. Okay, and again, plug them back in. Alright, I gotta go. I'm up to my 15-minute limit. Hope you have a wonderful class. If you have any questions, make sure to email me. And here's your homework. Take care.